Hi! In this lesson we're going to take a look at how to find the limiting reactant or limiting reagent for a chemical reaction. So here we're given calcium bromide and magnesium chloride as our two reactants, and we see that we're given two masses, 300 grams versus 190.6 grams. Now when first learning about limiting reactants, our initial instinct is to say, oh, well, looking at these masses, we have less of the magnesium chloride, so that means that this one must be what limits our reaction, because we have a smaller mass. But the most important thing to keep in mind about limiting reagents is that you first have to convert to moles before you can compare your reactants to decide which one is going to limit the amount of product that you're able to make in your reaction. So let's practice by converting each of these to moles, starting with our calcium bromide, which we have 300 grams of. So to do this conversion, we're going to turn to our periodic tables and we're going to take a look at the atomic mass values for calcium and for bromine, and then we're also going to keep in mind that subscripts are going to play a role, because the subscripts indicate that we have only one calcium but we have two bromines, so we have to make sure that we account for that in our calculation. For calcium, in our periodic table, we see that it has an atomic mass of 40. For bromine, in our periodic table, if you look under the Br, in group 7, it's one of your halogens, you'll see that bromine has an atomic mass of 80, but here's the key, the subscript of 2 lets us know there are 2 of those bromines, so in total that's going to be a total of 160 for the bromine and 40 for the calcium. So in calcium bromide, we have a total of 200 grams in 1 mole of that substance. And if we multiply across and then divide, we get 300 divided by 200, and that comes out to, in decimal form, if you said 1.5, you're correct. 300 over 200 is the same as 3 over 2, or 1.5. So we have 1.5 moles of our calcium bromide that we're starting with in this chemical reaction. Now we have to convert grams to moles for the magnesium chloride, so that we can see how many of those we have. So here we're starting with 190.6 grams of the magnesium chloride. And this conversion is going to be slightly more complex because we see that we have decimals. It's going to make some of the computation a little bit more challenging, but the method is still exactly the same. We take a look at our periodic table. We have magnesium in the periodic table with an atomic mass of 24.3. And we have chlorine in the periodic table with an atomic mass of 35.5. And again, use the subscript. It's got a subscript of 2, which means we have to multiply times 2 to figure out the total that we would have for our molar mass of chlorine, and that would come out to 71. So when we add 24.3 and 71, we get 95.3 grams of magnesium chloride in 1 mole of that substance. So our molar mass of magnesium chloride allows us to make that conversion from grams to moles. And here, if we multiply straight across and then divide, when dealing with complex decimals, usually in chemistry classes you have the opportunity to use a calculator, so you can simply type that in. If not, then when you write out the long division of this, you'll want to move your decimal over 1 place and divide 953 into 1906, and that answer will come out to be 2. So we have 2.0 moles of magnesium chloride. Now that we've converted to moles, finding the limiting reactant just means we take a look at those numbers and we look at which one has fewer moles. In this case, it's the calcium bromide. So the calcium bromide, even though we started with a larger mass, that will actually be the substance that limits how far our reaction can proceed or how much of our product we can make. In this particular reaction, you would use up all 300 grams of the calcium bromide before the 190.6 grams of magnesium chloride had been used up. So you'll have a little bit of magnesium chloride remaining after all of your calcium bromide has been reacted. And this introductory problem right now only has coefficients of 1, so we don't have to worry about looking at the mole fraction between different substances and comparing those ratio of the number of equivalents of one to another. We will take a look at that in another problem in our next video, where we cover slightly more advanced questions on limiting reactants. If you have questions, please feel free to visit our website at www.sandersontestprep.com. The link is in the description below. Thanks for watching.